Okay, today's lesson is the empirical rule. It's, in other words, I don't know whether you heard of this. It's a 68, 95, 99.7 rule, because that's what we're going to use, like 68% of the bell curve, the area under the curve. But we are going to use the normal distribution right there. And of course, the middle one is mean, the average. The z-scores between -1 and 1, which just means one standard deviation above the mean, or the one standard deviation below the mean. So let's have a look at the empirical rule here. So approximately 68% of scores lie within one standard deviation of the mean, like, above 1, below 1. I just put all these colors in there so for you to remember. That's the 68% of the bell curve, okay, the area we're talking about. And then 95%, okay, so the z-score between -2 and 2 we're talking about here, 2 and -2. It's the actually 95% of the bell curve. Well, that sort of makes sense. And then 99.7% of the area is the with the z-scores between -3 and 3. Now, just the thing that you have to remember, because it's symmetrical, 68% is the two areas combined, isn't it? Right? It's not just one whole thing. So you can halve it if you want to find just the one part of it. Okay? So because 34% each. Okay? And what if it's the asking for something, it's not a 68%, but if it's a above 1, 2, 3, like 16%. So you need to remember that as well, because if it's a 68% in the z-scores between -1 and 1, the rest of them, it's a 32%. Okay, rest of the area. So think that as well, because the whole thing is 100%. So you do need to start thinking. It's not, it seems like a very simple, but there's a lot, like a little bits here and there sort of involved. You need to start thinking. Now, this is from the formula sheets, the reference that you're going to get in for HSC. It's in there. Okay, so you don't really need to memorize as such because it's given, but I think it's good to just remember it, so you don't really need to go back and check, So 68, 95, 99.7%. So let's have a look at the example 15. A data set is normally distributed, so it's a normal distribution, obviously, with mean 20. So my mu, the middle of the bell curve, is 20, and standard deviation, my sigma, is 3. Okay, so it's going up by 3, going down by 3, okay, from 20. Okay, so what percentage of scores lie between 17 and 23? So the first step is to draw your normal distribution, PDF. So if I do that, so the information I got from the question is right there, and I'll put all that in there. So I add 3 on my right hand side, so going up by 3, on my left going down by 3. Okay, so that's what we got, and it says here 17 and 23. That's the this part, isn't it? And that's obviously 68%. Okay, so the answer is 68%. The next one, 14 and 26, is exactly the same, but we've gone down to between 2 and -2 now of the standard deviation. So that's 95%. Okay, so these sort of questions are now like sort of confirming the rule. That's all. And here is 11 and 29 is our like last ±3 right there. Okay, so that's not too bad. Okay, so that's 99.7. And if this question was asking about more than 29, so if it was like here, you probably need to calculate 100 take away 99.7 and then halve it, because you got two tails here, isn't it? Right? That each one is half of 0.3%. Okay, so it'll be 0.15. So that's 0.15%. Okay, and also here is 0.15%. So I'm just giving you a little bit of information that you might forget to count on, just because you're really focused on the 68%, 95%, 99.7%. You're not going to forget about the rest of it, just little tails at the end. And it's a symmetrical, so you need to halve it if you want that one of them. Okay, part B. A normal distribution has mu, which is the mean, 65.2, and the standard deviation is 1.3. What percentage of scores lie between? So first thing first, you need to draw the normal distribution, the bell curve. Okay, so with mu in the middle, 65.2, and then plus 1.3 each time when you go up, and then when you go down, minus 1.3. And then it says 61.3 and 65.2. It's the on the left-hand side part. Okay, so the best thing is if this was a whole 6 areas, I'm talking about this, like I think it was a 1, 2, 3, 4, 5, 6 part, and if it was a whole 6 of them, it's definitely 99.7%, isn't it? Because it's the plus minus 3 section, but it's only half of it. So I'm just going to do 99.7% divided by 2, and just half of that will give me 49.85. And don't forget to put percentage. Okay, so that's what we're going to get. Okay, next one, 65.2, right there in the middle, and then going up by 1.3, which is 66.5. Okay, so roughly it's talking about just half of 68%, really, isn't it? So I think the best way to do this kind of question is you have to think of as 68, 95, 99.7, and then whether you halve it or put it together. Okay, so in here, this is definitely in the zone of 68%, but it's only half counted. So what I'm going to do is a 68% divided by 2 will give me 34%. So next one. Okay, this is a little bit tricky because it's not in a nice sort of symmetrical area we are looking at here. So 62 right here, 2.6, and a 69.1 at the end. Okay, so it's a couple of ways you can do. This is one of them. So what I've done is I put the whole thing that I could count on between 68, 95, and 99.7, and that was 95. Okay, it's not quite 99.7 because the one part is missing, but I can get the full 95% area, and there's a little extra bits that I need to add on. Okay, and that is the where areas 99.7 lies. Okay, when I think about it, what I've done is that 99.7 take away 95% will give me the each end, the little bits of each end, isn't it? Okay, that I'm going to divide it by 2, because I'm just counting on just the one part of that, the middle tail, if you like. So that will give me 2.35%. And all I've done is I'm just adding 95% with that 2.35%. Okay, So if I do that, I will get 97.35%. Okay, I'm sure there's other way of doing this, and you're welcome to do whatever you feel comfortable. But this is just one of the ways I've done. Okay, I'm just going to show you. This is the HSC, the reference sheet that you're going to have. It's on the second page. On the right hand side, there's all the statistical analysis, and that part that has all this normal distribution there, right there. So when we talk about normal distribution, it's just the bell curve, okay? And then the one that we've done, the continuous random variables, remember this one? So that's our PDF here that goes equal to 1. And this is another CDF that it's going to give us the general formula from A to X, A to here is R. So that's what it is, okay? So you don't really have to memorize by heart, but I think it helps if you do. Well, that's all for today's lesson. Well done, people.